So you see, continuing our last discussion right here, we said then that this is our pattern right here. Whatever x to the nth power we find, when we take its derivative, and this time I'm using the d dx notation, we were saying that if f of x was equal to x to the nth power, whatever that power was, then we should simply take the derivative by moving that exponent to the front as a multiplier and raising that to the n minus 1th power. This is our derivative rule rendered in the d dx notation. The derivative with respect to x of x to the n is n times x to the n minus 1. And we noted that when we took the derivative of x, we just got 1. Well, that fits this pattern because if we take x to the first and we take its derivative with respect to x, what we're really saying is that we've got 1 times x to the 1 minus 1, which is 0th power, and we know that x to the 0 is equal to 1. So what should we get if we take the derivative with respect to x of something like x to the 12th? Absolutely. We should get 12 times x to the 12 minus 1 power, which we say 12 times x to the 11th. This is probably one of the simplest rules that we have, but a lot can happen with it. Because this power rule can be extended, we can prove that it can be extended to both negative exponents and fractional exponents too. Like, for example, let's talk about the derivative with respect to x of x to the 2/3 power. Well, using this rule, what would we expect to find? 2/3 would be multiplied by x raised to the 2/3 power minus 1. Well, let's subtract 1 from 2/3. We just have to remember a little fraction, addition, and subtraction right here. We end up with negative 1/3 as the exponent here. And so our expression becomes 2/3 times x to the negative 1/3. And what we often like to do is to simplify our expression so that it is in the simplest form possible. That means getting rid of negative exponents. So we actually get the expression 2/3 times x to the 1/3 power as the derivative of x to the 2/3. Let's try it with this one. Now, you do have to be careful right here. I do have x as a positive exponent, but you'll notice it's in the denominator. And our power rule does not have a fraction. So what do? Well, the answer is to take advantage of our algebraic rule that tells us that 1 over x to the third is really the same thing as x to the negative 3rd power. And now we can apply our exponential rule here, our power rule, by taking the derivative, moving negative 3 in front, and taking negative 3 and subtracting 1 from it. And if you remember, when we combine two negatives, we get an even larger negative, in this case the negative 4th power. And again, getting rid of negative exponents, it turns out that our derivative should be written in simplified form as 3 over x to the 4th. So this is a really useful rule, and we're going to see that we're going to come across this over and over again in the next few chapters. So this is a really central one for us.